What is the nice thing that once you understand how the smooth geom works, you can also do the regression yourself, because it's very similar. How? Well, you use exactly the same functions as you use in the smooth geom. Going back here, LM, GLM, Lois. There are names of functions in R. Here we are. So you can use LM as a function to do a linear regression. Yeah, well, linear or nonlinear, it depends on what you write here and the formula that you give. How does the function work? Well, you need to give him data, he needs values, and you need to give him a formula. Here we are again, the thing with the tilde. And this time, the formula needs to be very concrete. So in front of the formula, you write your measurements, your y values, and after the tilde, you write the thing that you want to use as x values. Yeah? So in our case, going back to my plot, measurements are the weights column in the baby's data frame. The x-axis is the height column in the baby's data frame. So my formula looks like this. This is basically y, what we see here, y tilde x. But now we filled in what y and what x is. This will do a linear regression. It will produce a list. And in that list, you can find all the results of the regression. So you can find, among others, the residuals here, for instance. You can find the fitted values. These are your predictions. So it produces a list with a lot of objects, as you can see here. You don't want to go through them one by one. So your big friend here, when you're working with models in R, is this function, the summary function, because the summary function will produce a nice overview of the results of the model. So you do the model, you save the results in a variable, that variable becomes a list, and then you can use that list as an input for the summary function, and you will get the results. What do we see here? So we see the distribution of the residuals. So the residuals being the differences between your points and the line. So these distances. And here we are, intercept 26.6. So where does the line cut the y-axis? And you see that this is indeed correct, and you also see that here. This is the intercept. This is your first parameter in the equation. And then here, in the second estimate, here, 1.44, that's what you see here. That's an estimate of the slope of the line. Yeah, so what we call B here, this parameter, that pops up here. So under estimates, you can find the estimations of the parameters in the equation. And you can find here the R-square value, 0.04. So you see that what he's doing here in the smooth geom, I can do this myself very easily using exactly the same function as he is doing with exactly the same formula that he is using. Yeah, because the formula was determined here for the smooth geom. If you want to see one of these values, you have to do the regression yourself. So there's no way to access, except for this here, there's no way to access the results when you use the smooth geom. You can only look for the equation and the R-square, that's it.